Now I've started the class. So while we're waiting for the kids to join, let's do one thing. We'll quickly check the tables and then in the meantime some kids will join and then we'll get started. So table till 12 and 13 till 13. 13 4 ja.
52.
12 9 ja.
108.
11 7 ja.
What?
11 7 ja.
77.
7 9 ja.
63.
9 5 ja.
45.
4 8 ja.
32.
13 7 ja.
13 times 7. 91.
91. Wonderful. So I see one more kid here. What's your name, beta? Naina? Hello. I cannot see you. Yes, I can see you a little bit. Okay, yes. Now, so is it okay for me to call you Naina?
Yeah.
Yeah, okay. Hi Naina, welcome to the class. So Naina, you are in which grade?
Yeah.
You are in which grade?
Oh, I'm 5th grade.
5th grade? Okay.
Yeah.
So this is the class for kids from 3rd to 5th grade, and essentially what we do is we will learn everything that kids need to learn all the way till 5th grade, okay? And so Naina, I mean, there are a couple of things. I know I think you are in a car right now, so you will not be able to note down anything. And when I'm teaching, okay, so what I was trying to say was, in this class, whatever we do, you don't have to note anything. You don't have to worry about noting down anything. You have to only focus on understanding the concepts, and then we will solve few problems, okay? Because whatever we are doing, me and the board is getting recorded, okay? So you will have the video of the class that you can watch later to see what we learned. If you miss something, you can watch it and note it down, okay?
So your voice is not being recorded?
I'm sorry?
So your voice is not being recorded?
Me and my board, I am not without voice.
Me, your board, and your voice, and some other kids' voices.
Yeah, so let's not worry about that. That's out of the syllabus, okay? So again, when we have more kids in the class, I see that kids get tempted to talk about things which is outside math also. We'll try avoiding those discussions to the best possible extent. I'm not saying that you guys don't have to talk, but we'll try to make it more effective. Now, Naina, one thing better for you, okay? Hello, Akshara. So, Naina is a new friend in the class. Akshara, you and Praneet might want to say hello to her. Okay. So Naina, actually, what we strongly believe in is math is good or easy subject if we know tables, because tables are the backbone of math. The multiplication tables. So that's what I ask every kid to practice every day 5 minutes. So I'm just curious, do you know tables, Naina? Naina, have you practiced tables before? Naina, can you hear me okay?
Can you repeat that, please?
I was asking, have you learned tables, Naina? The multiplication tables?
Yeah.
Till which number? 8, 9, 10, 11, 12, 13, which one? And it's okay. I mean, whatever you have learned by now, that is enough. We will keep on learning. It doesn't take much time. It just needs a little bit of focus. That's what I'm asking. I'm just curious.
I know my multiplication, but I only memorized a few.
Okay, a few. Okay, so let me do one thing. I'm giving you a small task from now till next Tuesday, okay? We'll have class next Thursday also, which is day after tomorrow. But I'm giving you a week's time, and what I would request you to do is spend 5 minutes every day to memorize tables till 6. Let's plan till 6, okay? Okay?
Okay.
So in the meantime, I'm not going to check your tables today. Let me check tables for Akshara. Oh, you're upside down. Okay. Okay. Your camera flipped. You went upside down. So let's check Akshara's table. Akshara table till 12. 8 8 ja.
64.
9 7 ja.
63.
12 5 ja.
60.
7 8 ja.
56.
12 4 ja.
58.
11 7 ja.
Huh?
11 7 ja.
77.
12 9 ja.
108.
9 8 ja.
72.
Wonderful. Good job. So Naina, as you heard one of your friend talking about it, when we say 9 8 ja, that is 9 times 8. So I will leave it to you guys to figure out how you want to memorize it, but that's what we do in the beginning of the class, okay? So every Tuesday, I check tables. Prashant, Praneeth, hold it. Don't get tempted to talk, okay? Every Tuesday, I check tables for initial 5-10 minutes for all the kids, and then we get started with what we want to learn, okay? All right? So everybody is doing only 5 minutes every day to memorize tables. Whenever you are getting bored, you have nothing to do, check some tables quickly, okay? It's easy, not difficult. We just have to put some effort. That should be it. All right? Yes, Praneeth, you are saying something.
Oh, you answered my question. Like, what strategies do you recommend for memorizing tables?
5 minutes every day. That's it. Yep. Hey, Sweta.
Hi, sir.
So all the kids, we used to have class at 6:15 Central or 4:15 Pacific. But so 4:15 Pacific is where Praneeth is. Everybody else is in Central Time Zone. But due to daylight saving reversal, now the evenings are getting darker quickly. So that's why we are starting at 6 o'clock. Okay. So make sure that you set your alarm accordingly. Yep. Akshara, you're saying something.
Did you celebrate Halloween?
Yeah, I had a lot of candies which I'm not supposed to have. All right. So let's go back to the class. Sohita has joined now. So let's quickly check Sohita's table and then we'll get started with what we want to learn today. Sohita, table till
12.
8 9 yeah.
72.
12 5 yeah.
12.
5 yeah.
60.
7 8 yeah.
56.
4 9 yeah. 4 times 9 36. 2 3 yeah.
6.
12 8 yeah.
96.
Good job. Okay, so Naina, again, I'll keep calling out your name, beta, because this is your first class. So I will keep checking with you. Am I speaking okay or am I speaking very fast? How is it? Are you able to follow me okay?
Yeah.
Okay, cool. So now, okay, everybody go be on mute except me.
Sir, in our school we started multiplications.
Multiplications that you already know.
Yeah.
Okay.
It was so easy.
Yep. So everybody.
One.
Yeah, you guys in your school, they are just fooling around. They are teaching very simple things. We know a lot more than that. Yeah.
Yeah.
Alright, so I mean, with due respect for all the teachers, I'm not saying anything, but the syllabus is very light for you guys. That's why we are learning more and become much more stronger mentally when it comes to maths. What happened, Akshara? You guys will not let me teach.
What does syllabus mean?
Syllabus means what all you are going to cover in a year. You are in 4th grade, right? So what all you need to learn in 4th grade is called a syllabus for 4th grade.
Okay.
Yeah. All right. Now my request to everybody, let's not do a lot of talking. Otherwise we'll not be able to learn. Praneeth, hold it up. Now let's start with what we want to learn today. Okay. So in the previous class, we started learning geometry, where we were talking about different shapes. Basically, we started talking about quadrilaterals. And we talked about what is a rectangle, what is a square, what is a rhombus. We will touch upon all those shapes one more time. And then we'll talk about trapezoid, parallelogram, kite. And right now we are focusing on understanding the property of those shapes, because if we know the property very well, then we will be able to find out how to find out area, how to find out perimeter and those stuff. Okay, so let's spend some time to understand the property of all the shapes and then we'll move on. Is that okay, Naina? Okay, so again, Sohita, keep your video on. Nobody can hide from me in the class. Wonderful. So, right, same thing. So, Naina, question for you, beta, okay? I'm just trying to, and do you know what beta means? Child. Okay? So, I treat you all like my own kid, okay? That's how I treat you all. So, if I say something, if you're not sure what I'm saying, you can ask.
Beta means child.
Beta means child or son or daughter, whatever. Okay?
Is that in Telugu? It's in Hindi.
It's in Hindi. Anyways, let's not worry about it. I was just telling Naina that she should not think what my teacher is telling me. Okay? So Naina, a question for you, because these kids have attended the previous class. I'm just trying to understand what do you mean by a quadrilateral? Can you tell me briefly? Can you try teaching me that?
A quadrilateral is I forgot what specific number, but it's a shape with a specific number of sides.
Okay. So Praneeth, hold it. No, you cannot take away my job. I will let you guys talk when there's a reason to talk, when there's a need to talk. Let's not get tempted to talk, okay? Now, so for Naina to recollect.
Sir?
Yep.
I can't see you.
Disconnect and join, that's the trick. Okay? So, if you talk about a quadrilateral is a shape with 4 sides. If you're looking at this shape, or this shape, or this shape, or this shape, all these are called quadrilaterals because they have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So when you say it's quadrilateral is a shape or a closed shape which has 4 sides into it. Okay? So there could be different types of quadrilaterals. That's what we briefly talked about in the previous class. I will touch upon those one more time so that everybody is clear about those shapes, and then we will dig deeper into it. So as I explained in the previous class, which Naina did not attend, so I'm just repeating it, and everybody can just try to recall that. Okay, don't think that it's an opportunity for you to describe it. This shape, and this shape. These 3 shapes we talked about in the previous class, and we said this is a rectangle, this one is a square, and this is a parallelogram. Have you come across these names before, Naina? Rectangle, square, and a parallelogram?
Yeah.
Okay. Now, let's look at what is the difference between a rectangle and a square. Both are quadrilaterals because they have 4 sides. And also these corners are called angles. So again, Praneeth, Sohita and Akshara. I will not call out your names many times. Not because I'm ignoring you guys. Because since this is first class for Naina, I'll ask her few questions just to make sure that she's on the same page with us. So don't feel that I'm not letting you guys speak. I'm just focusing on making sure that everybody's on the same page. Okay. So this is the first quadrilateral. I'm calling this as a rectangle. This is the second one. I'm calling it a square. And this is the third one which I'm calling as a parallelogram. Now, would you ever call me Mr. Trump? No, right? I don't look like Trump. I don't have the properties of Mr. Trump. I'm a simple maths teacher named Birendra Kumar. And that is because I have certain properties of being Birendra Kumar, not Mr. Trump. Same way, these shapes are given names because of certain properties. Achha, hold it better. Don't.
Instead of calling you Birendra Kumar, you should just call you Mr. Kumar.
That's okay. Yep. Any which way. So what I was trying to convey here was that this is a rectangle, this is a square, and this is a parallelogram, and they are given a name because of certain properties, because of certain reasons. Now let's look at rectangle. Rectangle has 4 sides, 4 corners or 4 angles, 4 vertices, whatever you call them. And the property that rectangle has is the opposite sides. So this one and this one, this one and this one, they are of same length. Okay? The opposite sides are of same length, and every angle here is 90 degree. Okay? Now question to Naina. Again, I'm not trying to put Naina on the spot. I'm just trying to extract as much information I can from Naina. Okay? So Naina, what is a right angle, or what is a 90 degree angle? It's called a right angle. Do you know that? Yep?
Yeah.
Okay. And I have a very lame definition of a right angle. The angle when 2 lines meet and they seem to be right, meaning it's like 2 walls in the right position. Let's say the wall is like this. What does it feel like? The wall is going to fall. If the wall is like this, it's going to fall this way. If it's like this looks perfect, just right. Similarly, when you have 2 lines meeting in the right position, making an angle of 90 degree, that's called a right angle. So, now coming back to rectangle's property, it has 4 sides, that's why it's called quadrilateral also. The opposite sides are equal and every angle is 90 degree. Is that okay? That's the only reason we are calling it a rectangle. Okay? Now let's come to square. Square also has some interesting properties. Here also, opposite sides are equal. Every angle is 90 degree. But there's one more thing. This side and this side are also equal. Meaning all the 4 sides are equal actually. All the 4 sides of a square are equal. Okay? So, if you are looking at rectangle as a quadrilateral, opposite sides equal, every angle 90 degree. Square also is a type of a rectangle, but the only difference is here all the sides are equal. Meaning opposite sides are equal, these 2 sides are also equal to this one. Okay? So that's the main difference between rectangle and a square. Does that make sense? Naina? Okay? Is everybody okay? The difference between rectangle and a square? Okay. Now, there's one more thing. I have 2 lines. And I'm calling them parallel lines. I have 2 lines, I'm calling them parallel lines. Naina, do you know what do you mean by parallel line?
The parallel line is like, I forgot how to explain
it. So if you look at a pair of parallel lines, these are 2 lines. If you extend them in any direction, they will never meet. It's like a railway track. Have you seen a railway track, Naina?
Can you repeat that, please?
I'm sorry?
Can you repeat that, please?
I was asking, have you seen a railway track? The two metal lines on which the trains run, have you seen them?
Yes.
So a parallel line is like a railway track where you'll see that there are two solid metal lines, they never meet. Okay? That means the distance between the two lines remain the same. They will never meet, no matter how far you extend them. Okay? Yeah? So, why I'm talking about parallel lines? Now let's go back to what we have learned. A rectangle, opposite sides are equal, every angle 90 degree. And if you look at it carefully, this line and this line, they are parallel also. They will never meet. If you extend them very far, they will not meet. Okay? Here, these two lines also, if you extend them, they will never meet. Okay? So, I am coming back to the next concept or next shape, which is called a parallelogram. Why it is called parallelogram? Because the opposite sides are equal and also parallel to each other. Okay? So here you should see these two lines, they are parallel to each other and they are equal to each other. These two sides are parallel and equal to each other. So, this is the third variety of a quadrilateral where it has four sides and opposite sides are equal and parallel to each other. So, a rectangle is a parallelogram because here also the opposite sides are equal and parallel. A square is also a parallelogram because opposite sides are equal and parallel. Parallelogram is anyways a parallelogram. Okay? Yeah? So, if you have a parallelogram where every angle is also 90 degree, then that becomes a rectangle. If you have a parallelogram where all the sides are same and every angle is 90 degree, it becomes a square. Does that make sense to everybody, or I'm getting you guys worried? Sohita, Praneeth, Akshara, Naina, everybody okay? Praneeth is having some confusion?
Yes, a little.
Tell me, what is that?
I understand about the parallel, but what were you talking about like after that?
So, you know what is a parallelogram now, correct?
I just learned.
Okay, so I'm repeating what is a parallelogram. Parallelogram is a quadrilateral where the opposite sides are equal and parallel to each other. So this side and this side equal to each other and also parallel, meaning if you extend them in any direction, they will never meet. This side and this side equal and parallel. Okay? That's a parallelogram. Is that okay?
It will meet if you like curve it in. Or
Why would you curve it in? Do you draw a line like this or you draw a line like this?
well, we would draw a line like this, but it would cancel out parallel if you draw like this.
No, you will not do that. That's what I'm saying. Don't play with math, otherwise math will play with you. Okay? Simple thing. Simple thing here. I'll come to you, Akshara, okay? If I have a line, it will remain a line for the rest of its life. I will not mess with it and I will do this. I will not call it a line then. Okay? So if I'm talking about line or a side, it will not change its behavior or character. Imagine me teaching social studies tomorrow, starting tomorrow. I will mess it up. My behavior, my character is a math teacher. I'll do a good job as a math teacher. If I start teaching anything else, I'll mess it up. Same way, property or behavior or characteristic of this side or line, it will remain a straight line. So that's what I'm saying. These two sides are parallel, meaning I'm talking about these two sides. I'm not talking about any Tom, Dick and Harry here. If they are parallel, they will remain parallel, no matter how far you extend them. You keep drawing this, keep stretching this line for another 5 miles, they will not meet. Yes, Akshara, you were saying something.
The lines that don't meet are parallel. The lines that like basically meet are intersecting lines and perpendicular.
So exactly. So this pair of line and this pair of line are two different things. We are not trying to make any mixture out of it. When I'm dealing with these two lines, I will treat them as parallel lines and it has certain behaviors that we need to be aware of. If I am dealing with these two lines, this is a different combination. I will treat them differently. But I will not mix these two. Otherwise, that will create a lot of confusion. Does it make sense, Praneeth? Okay. Naina, are you okay, beta? So far? Sohita okay? Akshara okay?
Super, yeah.
I'm sorry?
Yes.
Okay, so now, after having seen a rectangle, a square and a parallelogram, what we concluded was that parallelogram is a shape which has opposite sides parallel and equal. It may or may not have all the angles 90 degree. When it is all 90 degree, it becomes a rectangle. When all the sides are equal and all the angles 90 degree, the parallelogram becomes a square. So every square is a parallelogram, every rectangle is a parallelogram. Is that okay? If I say, is every parallelogram a rectangle? Yes, Praneeth.
Can a square be a rectangle and a rectangle can't be a square?
Okay, ask this question to yourself. If you know the property of these two shapes, I'm not trying to avoid your question. I'm trying to make you think. Can a square be a rectangle? No, not always. Sometimes. A square will always be a rectangle because opposite sides are equal and parallel. Fine, 90 degree. That's a rectangle always. But is every rectangle a square? No. Similarly, I'm asking, is every parallelogram a rectangle? Is every parallelogram a rectangle? Naina, I'm making you think better. Tell me, will every parallelogram be a rectangle?
No.
Why? I want to hear your thought.
Well, it can. Because some of the lines on the rectangle never cross each other.
So let's see, right now you are in the car, so that's why you are not able to draw. But I will do it on your behalf. What is our definition of a parallelogram? It's a quadrilateral where opposite sides are equal and parallel. Okay? So that means this is a parallelogram and this is also a parallelogram. What is the difference between these two shapes that I am seeing? In this, here also my opposite sides are equal and parallel. 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 But the major difference is, in this case, all the angles are not equal to 90 degree. Here all the angles are 90 degree. So basically we are talking about two types of parallelograms. One parallelogram when all the angles are 90 degree, that is when it becomes a rectangle or a square. When all the angles are not 90 degree, it is just the parallelogram. Yeah? So rectangle is a variety of a parallelogram. Not all parallelograms are rectangle. Yeah? Yes,
So,
Akshay.
is that angle 50 degrees because the angle is basically going lower? It's not like straight like 90.
I mean, it might be 50, it might be 60, it might be 70, I don't know. Don't rely on my drawing skills. My drawing skills are horrible. You cannot measure what exactly it is. But what I'm trying to convey here is that parallelograms, when the angles are all 90 degree, that is when it becomes a rectangle. But they are still parallelograms where the angles are not 90 degree, so they are just parallelograms.
So you're estimating how much decorated it is?
I'm not estimating that. I'm conserving my energy for more important things. Why should I worry about estimating the value of this guy? I just see that the lines are not straight. They're just not looking right. That's it. Yeah? Alright. So, is that, let me check with Naina first. Then I'll go to Pranit. Naina, is this okay with us so far? Are you able to follow it okay?
Yes.
Okay. So, let me just repeat. We saw a rectangle is a quadrilateral where the opposite sides are equal and parallel. Equal and parallel, and every angle is 90 degree. That's what is a rectangle. We saw a square where all the sides are of same length and the opposite sides are also parallel and every angle is 90 degree. That's what is a square. Parallelogram is a broader category. It's a quadrilateral where the opposite sides are parallel and equal. The angles may or may not be 90 degree always. When the angles are 90 degree, it becomes a rectangle. When the angles are not 90 degree, it just remains a parallelogram. So these are the three shapes that we have talked about so far. And when we talk about lines being parallel or sides being parallel, what we mean is those sides will never meet, no matter how far you extend them. Yeah? Yes, Pranit, what was your question?
So that's why buildings are never structured like that, or they will just do this.
Yeah? Imagine that this classroom where I'm teaching, the floor where I'm standing and the wall behind me where the board is. If my wall, the classroom wall is like this, it might fall on my head. Yeah? One day. It will not be strong enough. If the wall is tilting that way, it will fall on my neighbor's wall someday. So that's why it's not right. So that's why this situation, this position where the two lines or the two walls meet is called the right angle, because this is just right. If it's not this, there's a problem. If this is not this, if this is like this, it's a problem. This is right. Yeah?
So if it falls like this, won't the roof fall?
That's a physics problem. We'll take care of it later. We will find out a handyman who can fix the roof or a construction worker. Let's not worry about it. So we saw a square, rectangle and a parallelogram. Let's go to the next shape. And right now I'm trying to play. So Naina must be wondering what kind of a teacher is this who's wanting to play. I always like playing, okay? I know I'm too old to play, but there's a child within me who plays with math. That's what I want you guys to do as well. Because when you play with math, it becomes fun. Now this is my square, okay? So far, okay? This is a square, all four sides equal, every angle 90 degree. Yeah? What I'm doing is, let me rotate this square. So this becomes my square now. I just rotated it, okay? I just rotated the square. I'm looking at it a little differently, okay? Now, I'm getting literally naughty, okay? I'm trying to squeeze the square. I'm squeezing the square. So what happens when I squeeze it, it gets squeezed. When I'm squeezing the square, what happens is when I'm putting pressure from these two sides, the square changes its shape. When I was applying the pressure on this one, what happened was the square got squeezed and became thinner and taller. Yeah? this side, this side, this side, this side shifted. Everything shifted because of the pressure that I was applying on the square. So this shape that is formed by squeezing a square is called a rhombus. This is called rhombus or a diamond. Have you heard about this name before? Had you guys heard this name before? Rhombus or a diamond? So now if you are looking at the property of a rhombus, the most important thing that you would want to know is a rhombus is a child of a square. Basically, when you squeeze a square, that's when you get a rhombus. So whatever was the length of the side, the length of all the sides remain the same because you're not cutting anything, okay? You're just squeezing it. So the length remained the same, but these angles changed. This, when you're applying the force, the angle was becoming bigger than 90 degree, and the other two corners, it became smaller than 90 degree. So that's the most important difference between a square and a rhombus. In the case of a square, all your angles are 90 degree. They are looking like this. When you squeeze from two corners, it becomes thinner and taller. All the sides are same, but the angles are not 90 degree. So that's the main difference between a square and a rhombus or a diamond. Does that make sense to everybody? Yeah? Was this a good playful act? Are you guys okay to accept your teacher playing with the shapes? Okay, yeah, Praneeth, go ahead.
Does it become a rhombus because the pressure they release it on the top?
No.
They release the pressure on the top?
That's a physics question. Force and pressure that you will learn in physics. What I'm trying to tell you guys is this is the outcome. See, we are not going to calculate how much pressure we applied here and how much pressure it released, where we are conserving energy. We are not talking about all that. What we are talking about is there was a shape called square and we squeezed from two corners. This was the original shape. This is the new shape. Okay. So, what is the difference between the shapes? That's what we are trying to understand and appreciate. Is that okay? Naina, Akshara, Sohita. Sohita, is the popcorn good? I'm just kidding. Popcorn is nice. Alright. Okay. So far, what do we have in our pocket now? We talked about rectangle. These are the babies from the quadrilateral family. We talked about rectangle. What is rectangle? Opposite sides equal, every angle 90 degree. Opposite sides equal and parallel. We talked about square. All sides equal, every angle 90 degree, opposite sides parallel and equal. Square. We talked about parallelogram, broader category. Opposite sides equal and parallel. Angles may or may not be 90 degree. When it's 90 degree, it becomes a rectangle. When it's not 90 degree, just a parallelogram. Okay. Then we talked about the fourth shape, which is a rhombus or a diamond, which is nothing but a distorted form of a square. When you squeeze the square from two corners, when you make it thinner and taller, that's what is a rhombus. All sides are equal, but the angles are not 90 degree. That's a deformation that happens when you are trying to make a rhombus. Is that okay so far? Naina, okay beta? So far? Easy to follow or difficult to digest?
Yeah, it's good.
Okay. Now, let's go to the next shape. Have you guys seen a kite before? Do you guys know what is a kite? Does anybody know what is a kite? Who are you talking to, Praneeth? Mute button.
I am on mute.
Yeah, now I was asking, do you guys know what is a kite?
Did you say type or tie?
Kite.
Kite.
Kite. K-I-T-E.
K-I-T-E. It's
Yeah.
like a diamond, yeah.
It's like a diamond, but not diamond. So let's look at it side by side and then we'll tell you. Again, I'm in a very playful mood right now. I'm wanting to play. This is what you guys told is a diamond or a rhombus, where all the sides are of same length and the angles are not 90 degree. Okay? Okay? Because we squeezed a square and we kind of distorted all the angles. Okay? So it's not a square. But all the four sides are same. So this is rhombus or diamond. Now, as I was telling you guys that I wanted to play, and I'm not sure about you guys, but when we were small, apart from all the games, when we were small, meaning when I was small, it was like 45 years ago, maybe 44 years ago, 42 years ago. So, we did not have the phones, the gadgets, or Roblox or anything. We used to play with physical stuff. We'll take some bats, some hockey stick, whatever.
Like cricket?
Cricket, hockey, football, soccer, whatever. Physical
You
stuff.
had no TV?
I did not have electricity either. Forget about TV.
You know when you were born?
I'm sorry?
You know when you were born?
I was born in 76. 1976.
Oh, 19.
Okay, so let's...
My dad was born in 1983.
Okay, so your dad is much younger than me. Let's come back to math. Now, so what I was saying was, we used to play with different things and kite was one of them. It's a toy that you can attach with a string and you can actually fly in the sky. So it is something like this. And this is really fancy, okay? You will see kites like this where people will make, smileys. And then they'll attach the string and then fly it in the sky, okay? This is called kite. Now, we're not going to talk about the smiley right now. You can decorate it the way you want to have more fun with it. But mathematically, a geometry wise, if you see a shape, this is also quadrilateral because you see four sides. It looks similar, somewhat similar to diamond, but it is different because only this side and this side are same, this side and this side are same. If you compare with the diamond, all four sides are same. Here only top two and bottom two sides are same. That makes the difference, okay? So if you look at a diamond or a rhombus and a kite, the main difference is here all your sides are same, here only these are same in pairs. These two are same, these two are same. Okay? If every side becomes the same, you will not call it a kite, you will call it a rhombus. Okay? Does it make sense? Naina, Sohita, Praneet. So, whenever you guys get a chance, when you talk to your parents, check with them whether they have played with the kites or not when they were small, like me. Okay? Okay? I'm sure they would have either seen it, they have played with it by themselves, or at least they would know what exactly it is. Now, we are going to come to the last shape of a quadrilateral, and that is called trapezoid. Anybody who has heard about it?
Yes.
Tell me, what is it?
So it looks like a car, maybe. At least a little of the car.
Looks like a car. Okay, let me create a car without a wheel. Yeah?
Yeah.
If I put the wheels here, then it will become a car. I will not call it a trapezoid.
No, we don't need a wheel.
We don't need the wheel.
We just need that.
Yeah. So again, here also if you guys see 1, 2, 3, 4 sides. So this is also a quadrilateral. And the only difference here is, or the only thing that we need to know about is a trapezoid or trapezium, whatever you have heard. is a quadrilateral which has only one pair of sides which are parallel to each other. They are not equal, only parallel. Okay? This side, if this is 5, maybe this is 12, maybe this is 15, I don't know. But they are not same. If this and this are both 5, this is not a trapezoid. This will become something else. Okay? So what I'm saying is, it's a quadrilateral, meaning a shape with 4 sides, where only one pair of sides are parallel. See, these two are not parallel. If I extend them, they will meet. They are not parallel, okay? But these two guys are parallel. They will not meet, okay? And the length of these two sides are not the same. That Sohita, be on mute, beta. Okay. Okay. So I'm just doing a recap of what we have learned so far. Sohita, mute yourself, beta. I'm hearing something that I don't need to hear. Okay. So we looked at what all shapes. So this is a family of shapes called quadrilaterals. Meaning shapes with 4 sides. We talked about rectangle. We talked about square. We talked about
Rhombus.
parallelogram.
We talked about rhombus.
We talked about rhombus. We talked about kite. And we talked about trapezoid.
Trapezoid.
Okay? So we just looked at the property of these things. Okay? We just try to understand what are these shapes. And in the coming classes, Sohita, be on mute, beta, when you're not talking. Okay? In the coming classes, we will learn a little bit more about these shapes. We just know their properties, but what do we do with that? If you guys just know that, okay, I'm a math teacher and I don't teach you guys anything, I'm as good as you being useless. Correct? Same way, if you just know the shapes and you don't know what to do with them, that information is of no use. So we will learn how to deal with these shapes, how do we calculate something about them. And there are 2 things primarily that we need to learn. One is called area and one is called perimeter. So we will try to learn about the area and perimeter of all these shapes, okay? Now my question to you all is, what is area?
Area means how much space it is.
How much space it needs. Yeah?
Area is also like, if you have units, like how many units are inside a box or anything. Like that type of shape.
Correct. So here, let's understand this in the most simplistic way. If I'm talking about this guy is a rectangle, this guy also a rectangle, this guy also a rectangle, this guy also a rectangle. Monster rectangle, smaller rectangle, baby rectangle, tiny rectangle. All these have they are called rectangle because the opposite sides are equal and parallel. Every angle is 90 degrees. That's why they are all rectangle. This is rectangle, this is rectangle, this is rectangle, this is rectangle. And if I'm wanting to play more, this is also rectangle. Okay? Yeah. So don't worry about it. I'm just telling you guys that all these shapes are rectangle. What is the difference between them? This is a bigger one. This is taking more space on the board where I'm trying to draw it. This takes less space. This takes even less space. This takes even less space. This takes least space. So area is nothing but the space taken by the object on the surface where you're trying to draw it. Okay? So this is more area, even less, least. This is just a representation of things. So this is just to understand. Let's say Now you guys are all small, much smaller than me, age-wise, size-wise also. If you look at my face, if you have to draw my face on a piece of paper, versus if you have to draw, let's say, Naina's face on a piece of paper, versus Pradeep's face on the piece of paper, or Sohita and Akshara, you will need a bigger paper for me to draw my face. It looks quite big. Yeah. For you guys, you need a smaller paper because you need smaller area for drawing it. That's exactly what area is. The amount of space taken by that shape for drawing it. Okay. Now look at this board. This board also has certain area. See, this is a rectangle. While I'm teaching you guys what is a rectangle, I'm actually using a rectangle for my daily work. Yeah. Look at the door of your house. Look at the walls around you. These are rectangles, mostly. Yeah. So we're not learning about rectangles because we want to get 100% in the exam. We are learning it because we deal with it every day. And if you are comfortable, don't do that, Pradeep. Keep it down. Because we are dealing with it every day. Okay? So all these shapes are all around us. We are just trying to understand what does it mean. Right now, Naina is in a car. Naina's car's wheels are what? Circles. Right? Before Naina started learning maths and geometry, she has already seen circles. This is all around us. So we are just trying to understand these things better and relate it. Okay? Yeah? So what is area? Area is the space taken by this thing. We'll try to figure out how do we calculate that. Okay? For different shapes that we have learned. Similarly, what is a perimeter? Perimeter is the length of the boundary. If I'm talking about this shape's perimeter, I'm talking about, let's imagine I have a string that I want to wrap around this whole shape. The length of the string will be my perimeter. This guy's perimeter will be this length of the string. This guy's perimeter will be this length of the string. This guy's perimeter will be this length of the string. This one. If you're talking about perimeter of a triangle, you're talking about length of all the three sides. If you're talking about length of perimeter of this circle, you're talking about the length of the entire string. That's all. So we'll learn about all these things. What is a perimeter? Length of the boundary. What is area? The space taken by something. Look at this guy. This is taking this much area. This guy is taking this much area. This guy is taking this much area. There is a way to calculate that mathematically. That is what we will learn in the coming classes. Does it make sense? Yes, Akshara.
Does a circle have a perimeter or not?
Every shape that is closed shape has a perimeter. Look at the perimeter. You have to measure the length from here, walk along the boundary of this shape and come to the point from where you had started. The entire length is the perimeter. How we will calculate, we'll figure it out. Okay? In the coming classes.
Circle, isn't the formula for finding out the area of circle pi r square into radius?
I don't know who you are. No, so we'll talk about that one by one, okay? I don't jump from one step to another. I'm just forcing you guys or navigating you guys to believe in what is the concept behind, and then we'll keep on learning the formulas. And when you guys grow up a little bit, we'll also learn how to derive those formulas also, okay? Not right now. At your age, if I teach you guys how the area of a triangle, area of a circle, area of a rectangle derived, how the formula came into existence, that will be a little too much for you guys to appreciate and digest, okay? So we'll learn about the formulas. I have a jacket. And I have a heater also in the classroom, okay? So,
Yeah, but it's a joke.
yeah. So don't worry about it. So net, whatever we learned, I hope it made some sense to you guys. See you guys in the class day after tomorrow as well. Alright? Bye-bye. Good night. Bye-bye.